In this video, I am going to discuss about whether these two given functions x to the power 2n and x to the power 2n plus 1 are one-to-one given that n is 1, 2, 3, 4 or n is a natural number. Let's consider the first case. Y is equal to f of x is equal to x to the power 2n. Is this a one-to-one function? Things are better understood if we take an example. So let's say my n is equal to 1. In that case, my function is going to be y is equal to f of x is equal to x to the power 2 times 1, which is just 2, right? X square. So the function becomes y is equal to x square. Now this function, by the way, is not a one-to-one function. Why? Remember, the definition of one-to-oneness is this. If you have two distinct values or two different values in the domain, that should give you two different values in the range. That means for two different x values, you should get two different y values. That's what the definition of one-to-oneness. Now for this function, y is equal to x square. If my x is equal to negative 1 and x is equal to 1, then what do I get? Y is equal to f of negative 1, which is negative 1 whole square, which is 1, and y is equal to f of 1, which is equal to 1 square, which is also 1. See, for two different values, 1 and negative 1, x has two different values, but y value is the same. Therefore, this function is not a one-to-one function. Now we can take this concept and extend it. Whenever you have a function which is of the form y is equal to f of x is equal to x to the power 2n, where n is a natural number, 1, 2, 3, 4. If n is a natural number, 2n is going to be an even number. So it would be x square, x to the power 4, x to the power 6, x to the power 8, x to the power 10, and so on and so forth. When the power is positive even number, the functions are not one-to-one. Why is that the case? Because if you take negative 1 and positive 1 or negative 2 and positive 2, both of these are going to give you the same y value. Or any number and its opposite is going to give you the same y value because of this even power. Because even power is going to kill this negative sign. So end result is going to be positive. Similarly, let's consider the other scenario where y is equal to g of x is equal to x to the power 2n plus 1. Let's consider n is equal to 1. In that case, is going to be x to the power 2n plus 1 is equal to x to the power 2 times 1 plus 1, which is x to the power 2 plus 1, 3, right? X cubed. So my function will be y is equal to g of x is equal to x cube. This function, by the way, is one-to-one. And if you graph it, it's going to look like this. I'm going to go back and graph the other one too. I just forgot to do that. So this is how x cube is going to look like. Y is equal to x cube, or the cubic function. Now as you can see, if you take two different values of x, you'll get two different values of y for this function anywhere. It doesn't matter where you are. Now let's take this example, y is equal to x square. If you sketch it, it's a parabola, by the way, going through the origin. Okay? It's opening up. So if you pick x is equal to 1 and x is equal to negative 1, the height is still the same, right, for both of them. So that's why for two different values, 1 and negative 1, the y value is the same, which is this point. So this one is an example where the function is not one-to-one. This one is an example where the function is one-to-one. In general, if you have x cube or x cube, x to the power 5, x to the power 7, x to the power 9, x to the power 11, x to the power 13, and so on and so forth, any odd positive number as an exponent, it is going to be a one-to-one function. Remember that. It's going to be one-to-one function. As soon as you have an x with an odd power just by itself, is going to be a 1-to-1. On the other hand, if you have an x with an even power, it's not going to be a 1-to-1 function. Now let me summarize what I just talked about. This is what I talked about. So if you have a function of this structure, x is equal to 2 to the power n, meaning x has an even exponent, right? Then the function is not 1-to-1, because two different values that are opposite to each other is going to give you the same y value. That's why, like 1 and -1, -5 and +5, 10 and -10, all of them are going to give you the same y value. I mean the positive and the negative ones. So that's why this function is not 1-to-1. On the other hand, if you have a function like this where the exponent is an odd number, by the way, the function is going to be 1-to-1, because any two distinct values, any two different values for x will give you two different values for y. I hope that this discussion was helpful. Thank you very much.